Okay, today we're going to go over section 9.2b, and we're going to continue on with Taylor's theorem. So yesterday we talked about Taylor's series centered about x equals to 0, but today we're going to focus on Taylor's series centered about x equals to a. So here we have f of x equals to f of a plus f prime of a times x minus a plus f double prime of a times x minus a squared over 2 factorial plus f triple prime of a times x minus a cubed over 3 factorial plus, let's do a fourth one, fourth derivative of f at a times x minus a to the fourth over 4 factorial plus, now we'll write plus dot 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 plus, and let's write the ones at the very end, the nth derivative of f at a times x minus a to the nth all over n factorial. That would be our general nth term. Now this is a more general form of the same thing that you guys learned the day before for Taylor's series centered about x equals to 0, because let me write what that one was. If we let a equals to 0, we would have f of x equals to f of 0 plus f prime of 0, f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 times x cubed over 3 factorial. And then our nth term is the nth derivative of f at 0 times x to the n over n factorial. So similar to what we had yesterday, we have all of the zeros are replaced with a's, and try to remember that this is like having over 0 factorial over 1 factorial. This is x minus a to the 1, and you can think of this as x minus a to the 0. So it does fit the pattern all the way through for n is greater than or equal to 0. So we're going to instead focus on all of these Taylor series centered about some number, not 0, so x equals to a. So that's what we're going to focus our 3 examples today. So the first one, we are going to find the third order Taylor polynomial for f of x equals to sine x about a equals to pi over 3. So instead of it being centered at 0, it's going to be pi over 3. So we're going to need, if you look at your formula up above, we're going to need f of pi over 3. We're going to need f prime of pi over 3. And we're going to continue to need f double prime and then f triple prime. How do we know where to stop? Well, when you have third order, that means you need up to the third derivative. So you keep that in mind. So trying to recall the notation that I would like for you guys to be able to do, to write it all nice and neat in one line. We're going to evaluate sine x when x is pi over 3. So that means sine pi over 3. Hope you guys remember your trig. It's going to be square root of 3 over 2. The derivative of sine is cosine. So when I evaluate at pi over 3, cosine pi over 3 is 1/2. And then we continue on with our derivatives. So we have negative sine x, again at pi over 3, gives us negative radical 3 over 2. And then we have negative cosine x at pi over 3, gives us negative 1/2. So all of these are our derivative values, similar to the derivative values we had the other day, and those are all going to get plugged in to here for our derivatives. So for f of a, f prime of a, f double prime of a, f triple prime of a, and so on. So let's actually take those and plug it in. So that means we have f of x. Actually, let's use a better notation. I'm going to put t sub 3 of x for the third order Taylor polynomial. The subscript tells me what order it is. So it's going to start out with f of a. So in this case, radical 3 over 2. plus f prime of a, so our first derivative that we have, which is 1/2, times x minus a, and I'm going to plug in pi over 3, plus f double prime, so that's a negative radical 3 over 2, times x minus a, which is pi over 3, and I still have to divide by 2 factorial, so squared here. And then I'll have f triple prime times x minus a cubed over 3 factorial. So this is what I have when I plug everything in, but I'm going to simplify things in order to write out my final polynomial. So I'll still have the 1/2 times x minus pi over 3. Now this next part, I'm going to rewrite 2 factorial and my 3 factorial by multiplying those out. So 2 factorial is 2, so I'm going to have minus radical 3 over 4 times x minus pi over 3 quantity squared, minus 1 over 12 times x minus pi over 3 quantity cubed. And this would be my approximation for sine x about pi over 3. That's my third order Taylor polynomial. That's our answer. So let's try a second example. Let's approximate our function f of x equals to ln of x about a equals to 2 when n equals to 3. And n is the order, so this means third order or nth order. So our function is ln of x, so we need to find f of 2, f prime of 2, f double prime of 2, and f triple prime of 2. So f of 2 is going to be ln of x evaluated at 2. Then when we take the derivative, we have 1 over x at x equals to 2 makes it 1/2. Then we take the derivative again, negative 1 over x squared, which is negative 1/4, and then 2 over x cubed, which is going to be 2 over 8, which simplifies to 1 over 4. So again, these are the derivatives that we need to plug in. So my function, f of x, is going to be approximated by the polynomial, which I'm going to call p sub 3 of x. It's going to be ln of 2 plus 1/2 times x minus a, so x minus 2, plus f double prime of a times x minus 2 squared over 2 factorial. And then our last term here, plus 1/4 times x minus 2 cubed over 3 factorial. So in order to finish off, just clean up the fractions, really is all you need to do. So 2 factorial is 2, so I can write this out as 1/8. And then 3 factorial is 6, so this is 1 over 24. We have example 3. We are going to find the second order Taylor polynomial for f of x equals to 1 plus x squared about a equals to 2. F of 2, f prime of 2, and f double prime of 2. Second order means we go up to the second derivative. So f of 2 is going to be 1 plus x squared, evaluated at 2, so 1 plus 2 plus 4, or 7. And then f prime of 2 is going to be 1 plus 2x, which gives us 5. And then f double prime is just going to be 2. These are the derivative values, so we get to plug that in to our little formula for Taylor's theorem. So that means p sub 2 of x, my polynomial of second order, p sub 2, is going to be approximated by 7 plus 5 times x minus a plus 2 times x minus a squared over 2 factorial. So we can write 7 plus 5 times x minus 2 plus x minus 2 quantity squared. Find for me f of 2.1. Should be pretty easy using this little approximation. I can plug in 2.1, and you see how I just simply get 0.1 in here because 2.1 minus 2 is 0.1. And then I'll plug in a 0.1 here because I have 2 minus 2. 2.1 minus 2 again is 0.1 squared. So this is 7 plus 0.5 plus 0.01. So the answer should be 7.51.